Hello everyone, good evening. Welcome back to Wallah English YouTube channel. I hope everyone is doing great. So till last lecture we have covered some topics of precipitation, and today we are going to proceed further. So let's have a quick recap before moving further, then we'll proceed. Okay. So in today's class, basically we are going to discuss estimation of missing data first. Then we are going to focus on inconsistency of record. After that, we are going to focus on how to present our rainfall data. We have discussed some topics of rainfall data yesterday. I hope it is very clear to you. And then we are going to throw some light on average depth of precipitation. See, this is very important topic. Average depth of precipitation basically has been asked in GATE many a times, okay, repetitively. Okay, good evening. Good evening, Vishal, Sushil. First, everyone kindly comment that am I fully audible and visible to you all, and what things we have already covered in class. Let's have a quick recap of that. See, firstly, in the starting, let us have a quick recap of entire hydrology, what all the topics which we have covered till now. So firstly, we have discussed about water cycle. I hope you all remember it. Okay, basically in water cycle, I told you about evaporation, then precipitation, and then after all the losses takes place, we have discussed runoff takes place. Okay, so that was your hydrological cycle, which is basically driven by sun. I hope you remember that. Then after water cycle, I told you about catchment area. What is catchment area? What is watershed? Okay, sink. All these things we have discussed. I hope it is very clear to you. After catchment area concept, I told you about catchment leakage. I told you about that whenever surface divide and groundwater divide are not in same line, then leakage takes place. Then I told you about residence time. Okay, higher the volume in a given hydrological cycle phase, the more the residence time. Okay, like oceans have the highest residence time, as I told you already. Then so we discussed water cycle, catchment area, residence time, catchment leakage, all these basic terms. Then I told you about what water budget equation. Okay, very important. Many questions have been framed in previous year questions in previous year about water budget equation, and I told you how to remember it. PRGET. I told you about PRGET. P is the precipitation received by a certain catchment area or some reservoir like that, and this is the net runoff, net groundwater flow, evaporation, transpiration. See, all these phases are going out, they are moving away. Okay, so it is coming in outflow, this is inflow, is equal to delta S. Then we simplified it, which was nothing no more than P minus losses equal to runoff. Okay, this was our final simplified water budget equation, which I told you we are in on chapter 2 right now, precipitation. Then we'll move on to losses and then runoff. Okay, so this was our first chapter. After that, we started precipitation. In precipitation, the very first topic which I told you about, the causes of precipitation. Okay, can you tell me the causes of precipitation in the comment box? Can you tell me what are the causes of precipitation? I hope you remember it. The causes of precipitation was simply two facts were there. Sir, what were those two facts? Sir, the very first thing was that we should have more humidity. Yes or no? More humidity should be there. So if more humidity is there, sir, if more humidity is there, then I will say that condensation will happen and temperature should be low. That I told you. Then I told you about the types of precipitation. See, basically we discussed 4 types of precipitation. I hope you remember it. Kindly comment everyone, what were those 4 types? What were those 4 types of precipitation? The very first one was convective precipitation. The very first one was convective precipitation. I hope you remember it. Convective precipitation, yes or no? Then the second one was orographic. Okay, the first one was convective precipitation. Then we have chorographic. See, in this convection cycles took place. Orographic was the one in which moisture laden winds were forced to move up through the mountain barriers. Then we have discussed about, sir, after orographic, sir, you told us about frontal was the fourth one. Then cyclonic was there. Okay, in cyclone, sir, you told us it is a low pressure region in which circular wind motion takes place, and in northern hemisphere, sir, cyclones are moving in anti-clockwise direction and vice versa in southern hemisphere. I told you about this thing. Okay, at last we have discussed about frontal, where where warm and cold air masses are coinciding to precipitate. Okay, so these were the types. After this, we went on to forms of precipitation. In forms of precipitation, I told you about the very first one, which was rain. Rain drop size was somewhere between 0.5 to 6 mm. I hope you remember that. Then we went on to classification: light, moderate, heavy rainfall. In light, we have rainfall intensity less than 2.5 mm per hour. Okay, that we have discussed. Then 2.5 to 7.5, and in heavy we have rainfall intensity even more than 7.5 mm per hour. Okay. Then we discussed about snow. Average density was 0.1 gram per cc. It is opaque. Then we discussed about sleet, which is mixture of snow and rain. Then we discussed hailstorm. After hailstorm, we discussed about your drizzle. Okay, in drizzles, drop size is less than that of rain. Okay, even less than 0.5 mm. Intensity was 0.1 centimeter per hour. Then we discussed about glaze. Okay, I hope you remember it. After this forms of precipitation, we went on to measurement of precipitation. In measurement of precipitation, sir, you told us the fact that there are two kinds of rain gauges. Okay, the very first one is your recording type and non-recording. Okay, in non-recording, sir, you told us about the Simon rain gauge, which should be placed in an open area, and its height is 30 centimeter. So diameter is 5 inches. Okay, I hope you remember that. Yes or no? So that was the case of your Simon rain gauge. Then in recording types, a tipping bucket was there, weighing bucket was there, natural siphon type was there. Natural siphon type was the standard recording rain gauge of India. Okay, that was important, which gives you mass curve. So after that, we went on to preparation of data. Okay, after that, sir, we went on to rain gauge density. Let me remove this. After that, we went on to rain gauge density, and I told you that at least one rain gauge should be there in 520 kilometers square in plain areas. In one station should be there in 260 to 390 kilometers square in moderately elevated 1000 meter area, plateau region. I told you about that. And one station should be there in 130 square kilometer when we have hilly area. In hilly area, sir, we need more rain gauge density. After that, sir, we went on to adequacy of rain gauge stations. I hope you remember this. In this, this is a topic which we have already discussed in the last class. I hope you remember it. Yes or no? Great. Perfect. So what we discussed here, that in adequacy of rain gauge, we discussed that number of rain gauges which are required for given error epsilon or E is none other than CV upon error whole square. Okay, this formula you have to remember. And we also solved one question. In the very first step, you have to do what? You have to find the mean precipitation, then you have to go for standard deviation, then coefficient of variation, and like that. Okay, so these are the steps. We have solved one question. Okay, I also told you about CV. I also gave you example of batsman in which with the help of which you are able to understand what is coefficient of variation exactly, because see, all the data varies. Okay, every time you will not get the same observation. This is the ultimate fact. Yes or no? Every time you will not get the same value. Yes or no, dear? Yes. So in places where we experience less rainfall, in those areas, sir, variability will be more. Okay, you will see much variation is there in the rainfall data. And where rainfall is happening at a much frequent rate, or where we have more rainfall, there you will see that variation is not that much. There you will see that variation is not that much. Okay, so this is the ultimate thing which you have to remember. So coefficient of variation was significant. Then we solved one question. Okay, such type of questions can be framed in your GATE examination or any kind of examination in which about optimum number of languages they are asking. So I hope you can solve them. Okay, at last we went on to preparation of data. The data should be continuous and consistent. I told you about this. See, what is continuity? Continuity simply means, sir, that the rainfall data should not be missing. Okay, let us imagine, sir, there are 10 rain gauges in our catchment area. All those should be working. If by chance one or two stations are not working, then I will say that my data is discontinuous. Okay, yes or no? I told you about that thing. Yes or no? Perfect. Perfect. Now we'll proceed further. Okay, now we'll proceed further and discuss about in today's class. The very first topic will be how to make our discontinuous data into a continuous one. If my data is discontinuous, how I will make it continuous? That is the ultimate objective. Okay, so first we'll discuss that, and we also discuss some more topics like what is normal precipitation, what is average annual rainfall, how it is measured. Okay, and everyone kindly comment what is the average annual rainfall in India. One of the important facts. Okay, you have to remember this. So average annual rainfall in India is how much? 119 centimeter, 118, 120. All options are all options you can see in your examination. And the water year basically starts in from 1st June to 31st May. From 1st June to 31st May is your what water year. Okay, okay, yes, perfect. Now the topic is estimation of missing data. So whenever, listen very carefully here, now we are going to understand the methods, okay, and from those methods we are going to uh, learn the formula, and from those formula we are going to solve one okay, we will solve one example, okay, one illustrative example, so that everything is clear to you. Okay, so whenever there is a break in record means if some data is some data is missing, or you can say that by chance if any rain gauge is not working, okay. See, some reasons are there. Maybe absence of observer is there, maybe there is no observer to measure the rainfall. Then in that case, sir, you will not see the then in that case, sir, you will not see what, you will not see the reading. Let us say failure of instrument has happened, so any possibility is there, okay. No matter what, but let me write one point here, okay. Due to any reason, if rain gauge reading, okay, if rain gauge reading is not available, if rain gauge reading at a particular location, if rain gauge reading at a particular location is not available, okay, due to any reason, if rain gauge reading at a particular location is unavailable, okay, then we are going to apply these formulas, okay. If rain gauge reading at a particular location or station is unavailable, okay, then estimation of that missing data is done with the help of basically two methods, okay, is done with the help of two methods. Now we are going to discuss those two methods. Listen very carefully, okay. The very first method is your arithmetic mean method. Everyone kindly comment. First we are going to study which method, sir? At first we are going to study about arithmetic mean method, okay. Understood, sir? Now see what this method is saying, you have to understand very carefully. See, this method is saying if normal precipitation of selected stations is within 10% of that of normal precipitation of missing data, then this method will be used. What is the meaning of this? See, if you have to understand the meaning of this, we have to take an example, okay. Let us assume that we have a catchment area, okay. Let us assume we have a catchment area, and here we have basically, let us say, 4 stations. Let us name them. The very first one is A, then we have B, then C, and then D, okay. Just take an example. So sir, you are saying we have 4 stations, A, B, C, and D, okay sir, that is very clear to us. Now see, normal precipitation of each and every data is given to you, okay. Let me draw one line here. Yes, now normal precipitation of all the data is given to you. Normal precipitation is given to you. Let us say this is 95 centimeter in a particular see, I told you about normal precipitation, okay. Can you tell me what is normal precipitation in the comment box till I am writing the data? Can you tell me? Great, dear, great. Wait a second. Can you tell me the meaning of normal precipitation? See, normal precipitation means we are taking average for last 30 year, okay. I told you about this yesterday, like what is normal precipitation. Wait a second. Okay, now it is very clear to me. Yes, so yes, average precipitation of a day, month, or year up to 30 years. Yes, great, that's great. Okay, Sarthak, don't worry. Okay sir, so normal precipitation of these 4 stations are given 95 centimeter. So this is normal precipitation in a of a year, okay. For last 30 years we have taken the average. at station A, this is station A, rain gauge is there. At station A, we have taken the average for the last 30 years consecutively, and the value which we are getting is 95. At B, we are getting 97. At C, we are getting it as 106 centimeter, and at D, we are getting it as 100 centimeters. Okay, so these are the normal precipitation. See, normal precipitation is a different thing. Now, precipitation in a certain given year. Okay, let us say precipitation in 2020. Okay, any year you can suppose. Okay, any year you can suppose here. Let us say 2020. So these are the annual rainfall of 2020. So at station A, let us say what reading we have observed. Let us say we have observed 120 centimeter. Then let us say at B, we are observing 90 centimeter rainfall in this year 2020. Okay, yearly rainfall of that given particular year. Okay, that is given to us 90 centimeter. Here, let us assume, wait a second, let us say, again, let us say it is 90 centimeter. Okay, just an example. Okay, we can frame any type of question here. Now, but at station D, sir, in this particular year, we don't have the value. Sir, we don't have the value somehow, no matter whatever the reason is, but sir, we don't have the station data at D. Okay, we don't have this data. Why? Let us say instrument failure is there, or let us say absence of observer is there, but we don't have this data. So what I will do now, I have to find the missing data with the help of arithmetic mean method. So arithmetic mean method is applied when, now listen very carefully, the condition. Arithmetic mean method is applied only when the normal precipitation of selected stations is within 10%. See, first what we have to do, now listen very carefully. See, the station whose data we don't have, we have to take the normal precipitation of that station. Okay, sir. So at D, sir, we don't have this year's data. So what is the normal precipitation here? Kindly comment, everyone. What is the normal precipitation here? Everyone kindly comment. Sir, normal precipitation here is 100 centimeter. Okay, so we will take normal precipitation of station D, which is none other than 100 centimeter. Then what we will do, sir, we will increase it by 10% and we will decrease it by 10%. Okay, 10% we have to first we have to increase it and then we have to decrease it 10%. Listen very carefully. Okay, yes or no? So what I will do now, increase it by 10%, so and decrease it. So if you will decrease it by 10%, you have to multiply it by 0.9, you will get 90, and when you will increase it by 10%, you have to multiply it by 1.1, 10% extra, then it will be 110. I hope this is very, very clear to you. You can decrease this number by 10% and increase it by 10%. So this will be the value. Now, all the other normals, okay, what are the other normals? Sir, 95, 97, 106. Okay, you have to check whether the selected stations, see, we have selected 4 stations here. Okay, we have selected 4 stations, 1 is missing and other 3 are near to it. Okay, so all these 3 stations normal values are lying within this range or not? Tell me. Is 95 coming between this? 97 is coming between this? 106 is coming between this? Yes, sir, it is sure. Then I will apply this arithmetic mean method. Sir, you are simply saying that normal values, let us say we have A, we have B, we have C. Okay, all the other normals, or you can simply say that normal precipitation of selected stations. And sir, which are the selected stations here? Sir, A, B and C. Sir, are those normal values lying within 10%? Okay, are lying within 10% plus minus 10% to that of our main normal, our missing data normal, that is normal at station D. Sir, you have increased it by 10%, then you have decreased it by 10%. If all the other normal values, are lying between this range, then I will apply arithmetic mean method. Yes or no? I hope this is very, very clear. Okay, can you tell me that all the normals are coming within this range? Yes or no? Yes or no? They are coming within this range. If they are coming within this range, then I will apply arithmetic mean method. Okay. Now how I will estimate the value of precipitation, at station D? Simply you have to take arithmetic mean of all the other values. Okay, if you want to find this one, precipitation in 2020 at station D, then what I will do? I will take average of all the other values. Okay, you cannot let me write x here. Okay, let me write x here because x is unknown. So what I have to do? I have to simply take the precipitation values of all the other stations simply in a particular year and divided by m. What is m, sir? What is m? M is nothing but number of working stations. Okay, divided by m simply. What is m here, sir? M is number of working stations. In our example, what is the number of working stations? Can you tell me? In our example, what is the number of working stations? Can you tell me? Kindly comment again. M is what? Number of working stations. So this is the formula with the help of which we will be able to find the value of precipitation at that station whose data is missing in that particular year. Yes or no? Perfect. So can you find the answer? So we will solve it now. Find what will be the precipitation at D. Sir, we simply have to take the average value of all the other precipitations. Okay, this is important. This can be asked in your examination. 3 is the number of working stations here, ABC. So 120, 90, 90. Okay, 120, 90. See, let us not take this value as 90. Let us change it. Okay, let us take it as 105 so that it is not same. Okay, so let us take this value as 105 divided by 3. How much you are getting? Kindly comment everyone. How much we are getting here? Tell me how much we are getting here. This is simply PD. How much we are getting here? This is 210, 310, 315 divided by 3. It is 105, I guess. Okay, 105, which means this value will be 105. Yes or no? Perfect. 105 is the correct answer here. Okay, great. Which means that if we don't have this data, we can take its value as 105 so that our data becomes, now tell me, our data will become continuous. From discontinuous, my data has become continuous. I hope this is very, very clear to you. Yes or no? Perfect. So tell me if this arithmetic mean thing is very, very clear to you. Now the second method. Now we have the second method, which is normal ratio method. Okay, which is even better, which will even give you better results. Now the next method is your normal ratio method. Okay, now what we have to do here? See, here all the other normals are lying within plus minus 10% range. All the normals are lying within plus minus 10% range. Yes or no? But in the normal ratio method, you have to see, listen very carefully here. In normal precipitation method, the very first thing is that the selected stations normal value are lying outside. If even one value, like A, B, C, 3 stations we have, if even one value is lying outside, if all the 3 values are lying within the 10% plus minus 10% range, then no problem, sir. Then I will apply arithmetic mean. But even if a single value is going outside this range, then I will apply which method? Everyone kindly comment. Then I will apply which method? Okay, then I will apply which method? Then I will apply normal ratio method. Then I will apply normal ratio method. Okay, I will take example of this also. First, let me write this value, that if any of the normal values, let it be normal value at A, B or C, if, see here I am writing not equal. Okay, if any of the values are going apart, if any of the values A, B or C normal value are going outside this range, then I have to use this formula. Okay, now what is the formula, sir? See, formula is, see why the method name is normal ratio. First we have to understand what is normal ratio. Okay, first we have to understand what is normal ratio. So for this, first I will take the example. Let us again assume that we have four stations. Let us again assume we have four stations A, B, C and D, and we have first normal yearly precipitation for the last 30 years at all these four stations. Let us assume that. Okay. And the values which are given here, assume it as 100. Take this value 112. One is 95. Next is 89. Again we have station D is not working here. Okay, and precipitation value in 2020, in the year 2020 is given to us. Okay, precipitation value in the year 2020 is given to us, and it is given to us as, let us say, 97 centimeters. This is giving you 103. Okay, like that, and here we have it as 95 centimeters. So we have to estimate like what precipitation value will be at station D, that we have to estimate. Okay, yes or no? So this is very simple logic we have to apply here. Now, sir, what is the formula to what is the normal ratio formula? Tell me that. With the help of that formula, I will simply estimate missing data at station D. Okay, now you have to understand what is normal ratio. See, this is n value. Okay, see, this is n and this is p. See, this is n, this is p. So what I have to do, if this is n and this is p, what I have to do is see, first understand what is normal ratio. See, p by n value is called as normal ratio. P by n value is called as normal ratio. You can find normal ratio at station A, B, C or D at any value. Okay, at any station you can find normal ratio. Normal ratio means precipitation in a given year divided by the normal value. Yes or no? That is normal ratio. Now here you have to take, in this method, what you have to do, you have to take average of arithmetic mean of normal ratios. You have to take average of normal ratios. Okay, sir, how we will do that? You have to take what we have to do here, sir, we have to take average of normal ratios. So first we will write normal ratio at station A, then we will write normal ratio at station B, then what I will do, we will write normal ratio at station C. Okay, then we will take the average. Average means divided by m. What is m? M is the number of working stations. Okay, yes or no? Perfect. Now this will give you the normal ratio of data which is not there. This will give you the normal ratio at station D. This will give you the normal ratio at station D. This is the formula which you have to apply. Okay, again, what is the meaning of m here? M is nothing but number of selected stations, working stations. Okay, selected or working, whatever you can call it as. So here we take average of normal ratios. Here we take average of what? Normal ratios. Okay, so we have to apply this formula and simply find PD. We have to simply find precipitation at D, because at D we don't have the precipitation value. Yes or no? So what I will do here is PD upon ND. Simply we will apply the formula, is nothing but 1 by m. Simply take the average of all the normal ratios. We have P by N of A, then we have B, and then we have C. Simply apply this formula. So m is what? 3. Okay, PD we have to find out. ND is what? ND is 100. ND is 100. See, okay, one more thing. One thing which we have not done here is we haven't checked like if all these normals are lying outside this 10% range. Okay, first we have to check that. First we have to check it. Okay, so what I have to do here is we have to take plus minus 10% range. Tell me if these values are lying inside or outside. So first, the normal value at which we don't have the data, I have to do what? I have to increase it by 10% and decrease it by 10%. First I will decrease it, it will be 90, and then I will increase it by 10%. First I will decrease it and then I will increase it. Yes or no? Simple. Now tell me, if all these other normals, are coming within this range. See, tell me, 112 is within this range or not? 112 is lying between 90 to 110. Yes or no? Sir, no. Obviously no. It is not coming in this range. It is going outside. Now there is no need to check all the other values, because even if one value is going outside, see, normal at A is not coming in this range. Now if it is not coming in this range, sir, then obviously I am going to apply this formula. Yes or no? Yes or no? Okay, perfect. I hope this is very clear to you. There is no need to check for 95. 95 is coming within this, 89 is not coming. So two are not coming, one is coming, but no matter. If only one value is going outside, we will apply simply normal ratio here. Okay. Now PA upon NA. See, this is PA, this is NA. 97 upon 112. 97 upon 112. Then PB by NB, 103 upon 95. Okay, then PC upon NC, 95 upon 89. 95 upon 89, like this. Okay, so this is it, and ND is 100. ND is 100. So this will give you precipitation at station D. Tell me how much we are getting here. Tell me how much we are getting here. Yes, you are saying, Sushil is saying 100.57. Okay, great. Vishal, are you also getting the same answer? Are you also getting 100.57? Tell me. So this will be what? Sir, this will be the value. We can take precipitation in 2020 at station D as how much? 100.57 centimeter. Okay. Tell me also. Tell me, Vishal, you are also getting the same answer. Then I will proceed. I hope both these methods are fully clear to you all. So this is what? This is our estimation of missing data. Okay. I hope estimation of missing data is fully clear to you. So we have two methods to estimate the missing data. The very first one is what? The very first one is your arithmetic mean method, which we will apply only when the other normals are lying within plus minus 10% range of the normal precipitation value whose data is missing. And if it is going beyond the 10% range, then I will use normal ratio method. I hope it is very, very clear to you. Okay, Vishal is getting 98.5. Okay, now we are in trouble because we are getting two answers here. So let me also solve this one. Wait a second. What you are getting? Let me check it. $97. Then we have 103 divided by 95. Then we have 95 divided by 89. Great. We are getting it as 100.59. We are getting 100.59 is the answer here. Okay, 100.59 is the correct answer here. So you can solve it and get it. Okay, so I hope this is very, very clear to you. Now we'll proceed further. Now we have the second problem. Sir, the first problem was, if my data is discontinuous, I have to make it continuous. Okay, using this method. And also, sir, there is a limitation. Limitation is that if only one station data is missing, if only single station data is missing, then I can apply this formula. If any, see, then generally what happens, let me tell you. See, this is your catchment area. Let us say this station is missing, and let us say this station is missing. So what I will do, I will take some stations near to this station. Okay, we will select some stations. We will take some selected stations near to, which are located in the vicinity of this station which is missing. Let us say this is missing, and let us say this is also missing. Okay, so what I will do, I will select some stations which are near to it. I will take these three stations A, B, C, and then I will simply find how, then I will simply use the basic method which I have told you, and I will find the value of this missing data. Yes or no? And here, If we have another missing data, then I will select some stations. Then I will select some stations of these which are located near to this station, and from this set we'll find this missing data. Okay, so missing data analysis is basically done only for single value. Okay, that you have to understand. Okay, if two data are missing, then you have to select different stations and perform this entire analysis. But yes, if a station data is missing, then you can apply these formulas for a given station by particularly selecting some stations near to it. Okay, great, perfect. So I hope this is clear to you. So if station data is missing, then I can simply find it. Now the second problem is inconsistency. If my data is inconsistent due to some reason, sir, if my data is inconsistent due to some reason, sir, I have to make it consistent. Okay, I have to make it consistent. How I will make it consistent? That is the ultimate thing. Tell me how I will make it consistent. Now, sir, first tell me what is the meaning of inconsistency? What is the meaning of inconsistency here? See, inconsistency means if a pattern is changing sharply. Let us imagine that at a station we are receiving rainfall as such as 98 in first year, then in the next year we are getting it as 92, then in the next year we are getting it as 105. So station rainfall data which we are receiving here are more or less similar, but let us say after some year drastic change is there. Okay, sudden changes in the values are there. You are receiving rainfall now, let us say as 210, 250, like that. So what has happened here? You can see that after a particular year the pattern or trend has changed suddenly. Okay, drastic changes there. So what will happen here? If drastic changes there, then I will say that my data has become inconsistent. Okay, sir, there is inconsistency. Okay, so sudden change in trend of precipitation is termed as inconsistency. I hope this is clear to you. Yes or no? Now how I will remove it? There is a technique. The technique, yes, Vishal, you are absolutely correct. You are absolutely correct here. The technique is known as double mask curve technique. Now first thing is, like, why inconsistency occurs. The very first thing is why inconsistency occurs. Okay, see, consistency basically occurs because of these reasons which are mentioned here. Also more reasons are there, but some reasons I have mentioned here which you can see. The very first reason is that change in ecosystem is there, such as cloudburst, forest. You all know that forests are responsible for rainfall. How many of you know this? Forests are responsible for rainfall, you know it. But if in a certain area forest fire is there, then obviously the pattern of rainfall will change suddenly. Cloudburst is there, then also more rainfall will be there. If change in ecosystem is there, then you will see that there is drastic change. If there is change in old instrument, let us say we have brought some new instrument, and in that new instrument reading is almost halved. Okay, reading is almost half, that is correct, but reading pattern has changed. If any observer has changed, let us say a worker has changed there, so obviously the observer will take different readings according to what he or she has learned. Okay, according to its skill, he will change the method, of observation. Okay, so if observer is changed, method of observation is changed, or if there is a change in instrument, or if there is change in ecosystem as well. Okay, so because of these factors, you will see what, because of these factors, sir, what I will see, because of these factors there will be inconsistency. And the technique with the help of which I remove inconsistency of record is known as double mask curve technique. This is very important. Okay, double mask curve technique is a technique with the help of which we remove inconsistency. This technique is important because in examinations they will only ask you the name of the technique. Okay, so you have to remember why you have to remember which technique is used to remove inconsistency in the record. The technique is named as double mask curve technique. Okay, very important. This technique is very important. You have to remember it. Okay, understood. So I hope this is very clear to you. Now How this technique is working, that I am going to tell you. Okay, how this technique is working. See, firstly you need to understand why this technique is called double mass curve. Okay, firstly, let me tell you that here we have two mass curves. That's why the name double mass curve is there. Okay, so what we do basically, yes, perfect dear. Now what we do basically here, listen very carefully. So first step is let us assume a catchment area is there. Wait a second. Let us assume we have a catchment area here. Okay, let us say we have a catchment area here, and let us say this station is not working properly. In this station, let us say some problem is there. Let us say this is the problematic station. Okay, let us say this is the problematic station X. Okay, and what I will do, in the vicinity of this problematic station, we will select few stations. Okay, we will select few stations which are located near to this problematic station X. I hope this is very clear to you. You all know what catchment area is, and at the center line of catchment area we have the main stream, ultimately in which all the water drains off. I have told you this. So first what I will do, see what we have done here. We have selected some stations. We have selected some stations near to. We have selected some stations, sir, near to our problematic station X. Okay, okay sir. So simply you are saying, right, let me write down these steps so that it is very clear to you. Firstly, what we have to do, we have to select a problematic station X at which certain drastic change we have observed. Okay, we have to select a problematic station at which a drastic change in pattern of rainfall is there. Okay, so first we have to select it. Then what I will do, I will select few stations near to it which are known as base stations. Base stations are selected which are near to that problematic station X. Let me write here so that it is very clear to you. We will select certain base stations. We will select certain base stations. We will select certain base stations near to X. Okay, near to X. Let us say 5 stations or 10 stations, like that. Okay, say 5 or 10 stations, like that we will take. Okay, and in our example we have taken 5 base stations. You can count it 1 2 3 4 5. 5 base stations we have taken, 5 6, like that. Any amount you can take. We are simply taking it 5 or 10, like that. Okay, now what we have to do, now we have two datas. See, we have one data of the problematic station. We have the first data of problematic station at which, sir, we have observed inconsistency, where we have observed that data is changing drastically, yes or no. And at second data which we have here is the average value of all these base stations. Okay, we have two values. We have to draw mass curve for both. Now what I have to do, we have to draw mass curve for both first one is your station X. I hope station X you all can see here. And then the average value of the selected stations. We have to draw mass curve for both station X. First one is your station X, and then second one is, let me write it like this. We have to draw mass curve for both. Okay, the very first mass curve 1 will be for your station X, and second mass curve will be for second mass curve will be for average of base stations. Okay, average value of all these base station values. So what I will do, average precipitation value of selected base stations. For that I will draw mass curve. Okay, now let me explain it to you further so that it is further more clear. Let us imagine we have certain data here. Okay, let us say we have data for station X here, and we have data for average of all these 5 stations. Okay, so at station X, let us imagine, okay, here I will write mass curve value of station X, and here I will write mass curve value of P average. Okay, with the help of this example, everything will be very, very clear to you. So listen very carefully first. I'm just simply giving you the example so that everything is clear to you. Listen very carefully. Okay, so let us say we are considering year 2011, then we have 2012, okay, and so on and so forth. Like this, we have data. Okay, let us say we have certain data like this. So in 2011, in 2011, let us say the value of precipitation at X is something. Okay, let us say it is 50 centimeters. Then let us say at in 2012 the value is somewhere around, let us say 65 centimeter, like this. Okay, and so on and so forth. We have certain values. Okay, in 2022, let us say we have something else. So like this, values are there. Like this, values at station X we have received. Similarly, in 2011, in 2011, we have precipitation values in all these 5 stations. We have some precipitation values in all the 5 stations which are in the vicinity of our problematic station X. We will take average of all those 5 values. We will take average of all those 5 values in 2011. Let us say that value is somewhere around, let us say that value is somewhere around 56 centimeter, like that. Okay, then the average value of all these 5 stations in 2012 is, let us say it is somewhere around 62, like this. Okay, like this you have average values of all these base stations in the particular year. Like this, problematic station X data we have, and we have average precipitation values of all these selected base stations. I hope this is very, very clear to you. Now what I will do, I will draw mass curve. Now what is mass curve? See, if I want to draw mass curve for this value, then I have to simply do cumulative. Okay, see, up to this year the total value which we have received is 50. Up to 2012 the total value which we have received is, add them, add both of them. Cumulative data you all know how to find. 50 plus 65 is 115, like this. Similarly, if you have one more value here, 80, then you will add all these 3 values. In 115 you will add 80, you will get it as 195, like this. Okay, so like this you will simply find the cumulative value. Okay, you will simply find the cumulative value. So this is nothing but, this will give you nothing but mass curve. Okay, this is what, sir, this column will give me mass curve. This column will give me mass curve for problematic station X. Yes or no? This column is giving me the mass curve for problematic station X. Similarly, this column will give me mass curve for, similarly this column will give me mass curve for these selected base stations. Yes or no? Yes or no? Tell me. Selected base stations. Okay, I will illustrate this with the example. You can simply find the mass curve here. See, do the cumulative thing. Here we have 56 only, then add both of them. This is 118, then add all 3, you will get the value, then add all the 4, you will get the value. Like this you will obtain the mass curve for selected base station. So basically, sir, you have 2 mass curves here. Okay, basically we have 2 mass curve here. Okay, now what I will do, see, also one more thing we have to note, that we will plot it. Now we will plot this, but one thing which you have to remember is, we have to plot this double mass curve. Okay, plot this double mass curve in latest chronological order. Okay, see, we have to plot it in latest chronological order. See, what is the meaning of this? First I will draw the mass curve, double mass curve, so that it is very, very clear to you. Okay, first I will draw it, with the help of which you will be able to understand it. Okay, I hope till now everything is very, very clear to you. Till now no problem is there. So now we will draw what, sir? Now on the x-axis, wait a second, let me draw one graph here. Okay, so I will draw it from here. Okay, so we have two axes, you know, we have y-axis and we have x-axis. Okay, now we will plot it in, I am telling it to plot in latest chronological order. Okay, so let us assume that at y-axis we have asker for station X. Okay, and here in y-axis we have masker for the selected stations. Okay, see px, you all know summation px is nothing but accumulated annual rainfall. It is nothing but accumulated annual rainfall. Accumulated means cumulative. Okay, accumulated annual rainfall versus accumulated rainfall, annual rainfall for X, for station X. Okay, simply masker, and this is accumulated value for for base stations. Accumulated annual rainfall for base stations. Now sir, you are telling me one thing, that we have to plot it. You are saying sir, that we have to plot it in latest chronological order. See, what is the meaning of latest? So what I have to do here is I have to plot this latest data first. Okay, I have to plot the value which is written here, and I have to plot this value which is written here first. Then we'll go to 2021, then I will go to 2020, then I will go to 2019, like this. Okay, we have to go in reverse order. We have to write the latest data first. That you have to understand. Okay, so first sir, I will plot the 2022 data. Okay, 56 comma, okay, let me see the value, the first value. Okay, it is not given here. Let us assume some value is there. We will plot, we will put these values. Okay, we'll put these values and it will be coming somewhere here. Okay, then I will write 2020 data, 2021 data, then 2020 data, then 2019. Okay, then similarly we will keep on writing like this. Okay, let us say this is 2022 data, this is 21, this is 20, this is 19, this is 18, this is 17, like this. Okay, now before 2017, you are saying, before 2017 sir, we are seeing some jump is there. Okay, graph is going like this. Okay, let us say 16, 15, 14, and so on so forth. You are seeing that graph is going sharply. Okay, let me draw it with the help of a straight line here so that it is more clear. Okay, so 2017 sir, data is following some pattern, but after that sir, we can see what we are seeing, a sharp jump. We can see a sharp jump here. Okay, sir, we are seeing a sharp jump here. It will be some, see, obviously all the points will not be in perfectly in straight line. Okay, some will be lying here and there, so there is no need to worry. So what I have to do, see, obviously sir, we can say what we can observe from this graph, that after 2017 things has changed. Okay, after 2017 things have changed, and no matter what sir, now it is changed. So we will change the previous data before 2017. Whatever problem was there, we will try to adjust it. We will now change that data into the latest pattern. Okay, sir, you are simply saying that after 2017 rainfall pattern has changed. So what I will do, I will adjust the previous data, the rainfall data which is which we have before 2017. We will try to adjust it, and we will make the slope of this line. See, we will try to ensure that the slope of this line is also same. See, this is the slope of new pattern, new data. Okay, you know that after 2017 pattern has changed, yes or no? Tell me. After 2017 pattern has changed, yes or no? So what I will do here is that the data which is coming previous to 2017, I will shift it, I will change it. See, obviously you can see that these values are more. You can see that these precipitation values are more. I will reduce it to this. Okay, to this line. Okay, we have to adjust it. So okay sir, how I will do that? We have to understand. See, this is my actual you can say double mass curve slope. Let me write here. See, this is the this line is representing actual double mass curve slope. Yes or no? Actual double mass curve slope, which we will represent by MA, which I will represent by MA. But we don't want this. Before 2017, I want to convert this double mass curve slope into this one. Okay, we have to bring this line here so that now it is in continuation with the new data. Okay, we have to change it to this one. What is this? This is my, you can say, corrected double mass curve slope. This is my corrected double mass curve slope. Yes or no? So we have to change the data which is coming before 2017. This I will call it as MC. Okay, corrected double mass curve slope. So what I have to do simply is, see, from this similar triangle, obviously this is this graph has been drawn on graph paper. Obviously you all know this. So what we can do here is, listen very carefully. See, this value is what? This value will be what? This value will be, let us say this value is C, and this entire value, let us say this value will be A. Okay, so we have a correction factor. See, A is more, C is less. We want to shift all these values to this line. Okay, see, we have to bring this value from here to here. We have to bring this value from here to here. We have to bring this value from here to here, and we have to bring this value here. Okay, so we have to reduce all these values. We have to reduce these values. So how I will get the corrected values? Can you tell me how I will get the corrected values? So if I want to get the corrected values for problematic station X, see, similarity can be applied here. Okay, listen very carefully. See, we have similar triangle. Okay, see, this upon this, you can understand here, this is the corrected value, this is the original value. So corrected value upon original value is nothing but C upon A, is nothing but C upon A. So what ratio we can apply here? That corrected value upon P is equal to C by A. Yes or no? C by A, or simply you can say corrected double mass curve slope upon actual mass curve slope. See, this formula we can apply in order to get all these values corrected. Okay, see, you need to understand here, one more thing. This ratio is also known as correction ratio. Okay, this ratio is known as correction ratio. Correction ratio is what? C by A. C by A. See, this is the factor which will, with the help of which we will multiply all these values. We will multiply all these values and bring it down to this level. Okay, see, we have to reduce this value, we have to reduce this value, we have to reduce this value. So simply do what? Multiply all these precipitation values by C by A. Multiply all the precipitation values by C by A, and you will get the corrected value. Okay, see, what is PCX? You can simply say corrected value upon original value is nothing but C by A. Yes or no? This is what? This is C by A. Okay, correction ratio is what? C by A, or simply you can say here, corrected double mass curve slope, or upon actual double mass curve slope. Okay, this you can read out from the graph. So what is PCX? PCX is what? We will correct the values at station X. This is corrected precipitation value at station X. We will get corrected values, or correct the values at station X. Let me write here. Correct the values at station X, beyond the time. See, which time we are talking of at which we have seen the change. Okay, beyond changing time, using this formula. Okay, using this formula you can do it. Okay, so if I want to find this value, what I have to do? I have to simply multiply the precipitation value by C by A. Okay, so let us say this is total precipitation value, no matter, convert this, multiply only this value by C by A. Okay, when you will multiply this value by C by A, you will get this value. When you multiply this value by C by A, you will get this value, like this. Okay, so put the bigger values, and you will get, put the bigger values multiplied by C by A. Obviously C is less than A, this ratio will be less than 1. You will get the corrected values. Yes or no? So this is how we use double mass curve in order to obtain, our correct data, consistent data. Like this, before 2017, whatever inconsistency was there, no matter sir, no problem. Now it will be adjusted to our new pattern. Okay, that's why we plot it in reverse chronological order. Yes or no? Is this clear? Okay, we will correct it beyond the time where pattern is changing. Okay, correct the value that is station at beyond change time or from where pattern has changed. So I hope this is very, very clear to you. So this is double masker. Basically, see, this is not so important, but still I have told you entire thing, because in this playlist I will try to cover each and every topic in detail. Okay, so no problem, but remember it so that everything is fully clear to you all. If someone asks you like what is the technique which is used to remove that inconsistency, you will say double mask curve is the technique. Why it is double mask? Because curve, because in this we have two curves. One is for station X and the next one is for your average of the selected base stations. We will draw mask curve. Okay, so is this thing very, very clear to you? I hope this thing is very, very clear to you so that we can proceed further. Tell me if this thing is very, very clear to you. Then we will proceed with presentation of rainfall data. Yes. Yes, correction was applied with the help of similarity. Is this thing clear? Then we'll move on to presentation of rainfall data. Perfect. Okay, correction point we have to repeat. Okay, no problem. Okay, Sushil, listen very carefully. Correction point you are saying. See, let me draw this small triangle here. See, Sushil, this is the line which is going here. Okay, this is the let us say this is the value. Let us say this is the original value. We call this value as P. Okay, we call this value as P, and we have to bring this value here. Okay, we have to bring down this value because this is the actual double mask curve slope and this is the corrected one. Okay, so we have to bring the actual mask curve slope to corrected one. Yes or no, Sushil? Okay, sir, clear. So we have to bring this from here to here. Now from the graph only, see, this line will be drawn on the graph paper itself. So from the graph we can find this ratio. Let us say this value is C and let us say this value is A. Just imagine this is C is 0.5 and it is 1. So C by A ratio is what? See, you can understand here, this value here is what? PCX, and this entire value here is P. So corrected value upon original value, corrected value upon actual value is C upon A. Corrected value upon original value is C upon A. Yes or no, Sushil? I think with the help of this similarity everything is clear here. Okay, see, corrected value you have to find out. You have to find this value, and this value is already given to you, so you have to diminish it. So PCX is the corrected value at problematic station X. Okay, with respect to your average of all the selected base stations. So what I will do, PCX upon PX upon P is what? C upon A. So C upon A you can simply get from the graph, or it is nothing but the slope of, it is the ratio of corrected double mask curve slope upon actual double mask curve slope. That is also same. So from here you will find this. Okay, from here you will find this one. You will find this corrected value. Wait, let me write here so that it is more clear. This is A, this is C, this is PCX, and this is let me write here with the help of some different ink, this is P. Okay, so from here if you want to convert this value to here, PCX upon P will be what? C by A. This upon this, this upon this. Okay, like this. Now I think it is very clear to you. Now let's move on to the next topic, which is a presentation of data. Okay. Okay, now we'll move on to presentation of data. See, this is not so important. Okay, double mask curve is not important. That's why I'm not taking the example here. Okay, no question whatsoever have been asked, never ever. Okay, that's why I'm not discussing it. So we'll move on to some important topics. See, double mask curve is not so important. Only the name you should remember, but still I have taught you the entire process. Okay, which is also not important. But let us stay till here, because if I will try to solve the examples are so lengthy that it will take more than half an hour. Okay, that's I'm not getting into that because it's not important. If it is all important, then I would have taken it. Okay, now we'll discuss some presentation of data techniques. So basically we have some techniques to present our data. See, the very first one which you can see here is the mass curve. Okay, mass curve we have already discussed. We have already discussed just now double mass curve. So obviously you all know what mass curve is. We can present our data on mass curve. Now what is mass curve? Mass curve is simply what? It is plot of cumulative, or it is, okay, I hope you know what cumulative is. You have to cumulate the values. Okay, mass curve is what? Plot of cumulative or accumulated rainfall, plot of cumulative or accumulated rainfall with respect to time. With respect to time. This is what? This is your cumulative or accumulated rainfall with respect to time. Okay, so let me tell you with the help of an example so that it is very, very clear to you. Let us say in the very first hour, okay, in the very first hour, 0 to 1, we have hourly rainfall as, let us say we have hourly rainfall data. Let us say in the very first hour 5 centimeter rainfall has happened. Okay, in the next hour, let us assume 3 centimeter rainfall has taken place. Then in the next hour, let us say 1 centimeter rainfall has taken place, like this. Okay, and here we have cumulative rainfall. Okay, here we have to write cumulative rainfalls. Okay, so now write the cumulative value. See, in the very first hour, the total rainfall is 5 centimeter. In the starting 2 hours, can you tell me how much is the total rainfall in the first 2 hours? It will be 5 plus 3. 5 plus 3. What will be the total rainfall in the first 3 hours? It will be 9. 8 plus 1. Add all these values. So in the first 3 hours, 9 centimeter. In the first 2 hours, 8 centimeter. In the very first hour, only 5. So this is what? This is mass curve. If you will plot it here, see, you need to understand. If I will plot it here, I will write here cumulative rainfall. I will write here cumulative rainfall. Here I will write the time. So what I will observe here? See, cumulative rainfall versus time. What I will observe here, sir? I will observe that in the very first hour, I have to plot the value 5. Okay. So from 0 to 1, I will have the value from in the very first hour, I will plot 5. Like this, I will draw 5. Okay, then in the next hour we have to go to 8. So my graph will increase and it will be going to 8. Here we have 5, here we have 8. Then in the next hour we have it as 9. So graph continuously increases. Or it becomes constant. That is your mass curve. Okay, mass curve can never decrease. It only increases. Yes or no? Simple. Yes, we have different formats of data presentation. Perfect. So this is the very first one. I hope this is very, very clear to you. It is very simple. Okay, now we'll proceed to the second one, which is hydrograph. Okay, this is important. See, once in gate examination they have directly asked like what is hydrograph. They have directly asked it. Okay, they have asked mass curve also. So what is hydrograph? Hydrograph is nothing but plot of rainfall intensity. See, height means what? Rainfall intensity. Okay, height means what? Rainfall intensity. So plot of rainfall intensity versus time. Okay, this is your hydrograph. It is a kind of histogram basically. Okay, it is a kind of histogram. Histogram is nothing but like, it is like bar graph. Okay, let me show you how to draw it. But first let us try to understand what is intensity. Okay, first let us try to understand what is rainfall intensity. Listen very carefully. See, rainfall intensity is nothing but simply what is the amount of depth of rainfall divided by time. Okay, rainfall depth, when you will divide rainfall depth with time, you will get rainfall intensity. Yes or no? How I will plot it? Sir, tell me. So let us take a graph here. Okay, let us take a graph here. Okay, see on this y-axis we will have rainfall intensity, and on the x-axis we will have time. Yes or no? Here we will have intensity, which is represented by I. Rainfall intensity is represented by I. Okay, and here we will have time. Okay, so how I will draw it? So let us say in the very first hour, the rainfall intensity is 5 centimeter per hour. Obviously, rainfall intensity is in generally it is in centimeter per hour or millimeter per hour. Obviously, depth upon time, centimeter per hour. Okay, so 5 centimeter per hour, like that we will have the graphs. Okay, see, this is important. Like this. This is, let us say, first hour, second hour, third hour, fourth hour, like this. Okay, we will have all the values. See, wait a second. Yes, so this is 5, let us say this is 8, this is 7, let us say this is 4. So what these numbers are representing? These numbers are representing intensity in centimeter per hour. Okay, so if you want to find what is the total rainfall in the very first hour, you will say sir, 5 centimeter per hour rainfall has happened. So obviously in 1 hour, how much will be the total rainfall? If you want to find the area, here we have 5 centimeter per hour, here we have 1 hour, we will multiply it, we will get 5 centimeter. So this area will be 5 centimeter. This area will be what? This area will be 5 centimeter. Yes or no? Wait a second. This area will be what? This area will be 5 centimeter. Okay, this will be 8 centimeter, this will be 7 centimeter, and this will be 4 centimeter. Okay, so if you will multiply intensity by time, you will get rainfall depth. If you will multiply intensity with time, you will get rainfall depth. So like this bar graph, if bar graph is drawn, you will say it as, you will call it as hydrograph. Okay, yes, it is used for calculation of phi index. Perfect, great. It is used for calculation of phi index. Very important. Very good, Vishal. Everything is very clear to you. Perfect. We will, that's I have written here. Okay, like what is basic hydrograph? Hydrograph is very important. See, when you will calculate phi index, in the calculation of phi index, never ever, okay, in the calculation of phi index, never ever will start without drawing hydrograph. Okay, so hydrograph is important in the calculation of phi index. Phi index is a very important topic. Okay, many questions have been framed in gate examination. Basically in gate examination you will see that every time phi index has been asked. Okay, perfect. Yes, now we will discuss the last one, which is your moving average method. Yes, moving average method we have to discuss, the last method for presentation of our data. So what is moving average method? See, two things you need to understand here. First, let me tell you what is the meaning of moving average. Okay, let us take some, so only for the sake of explanation I am taking some data here, but yes, obviously the data which I will take will be very less in number. Obviously we take huge data such as 30 or 50 numbers, but I will only take 5 here, only for the sake of explanation. Okay, so let me take 5 rainfall datas. Okay, at a certain station, just try to assume at a certain station. Okay, at a certain station we have certain precipitation values. Okay, first, second, third, fourth, fifth. So let me tell you, in the very first year the precipitation value is 10, let us assume. In the next year the precipitation value is 12. In the next year the precipitation value at the same station, let us say it is 30. Then let us assume it to be 22, and then let us assume to be 16. Okay, so let us say this data we have. Okay, this is the data which we have. Okay, now if I will plot it, okay, if I will plot it here, okay sir, draw it. So if I will plot it here, listen very carefully. If I will plot it here, so I have to plot 10, 12, 30, 22, 16. I will write all these values on y-axis here, and on the x-axis we have time. Obviously sir, we have 5 values for time. Okay, 1 2 3 4 5. We have 1, sir, we have 2, sir, we have 2, we have 3, sir, we have 4, and we have 5. Okay, so 1 2 3 4 5 we have, and sir, what you are saying here is the first value is 10. Okay, let us say this is 10. Then we have 12. 12 is just above 10. Then we have 30. 30 is a huge value. Okay, it is very, you can say, going, it is shooting up. Then we have 22. Then we have 22 here, and then we have 16. Okay, so can you tell me what is the range here in the 1 year data? When we have taken one year data for a given station, can you tell me what is the range? What is the difference between highest and lowest value? See, the lowest value which you can see here is 10. Okay, so 10, 12, then we have 30, so then we have 22, at last we have 16. Okay, so we have values, but you can simply see here, sir, what we can simply see here is that data is fluctuating too much. Okay, data is fluctuating too much and it is varying from minimum value of 10 to largest value of 30. Okay, it is ranging from 10 to 30. So sir, simply you can see that range is, yes, 10 to 30. Perfect. A gap of 20 is there, yes or no? Great. Yes, Vishal, perfect. If you type, that's why I always say to comment every time. Yes. So this is what, this is the range. Okay, so for 1 year data, the range is from 10 to 30. Yes, you are right. Okay, now what I will do, I will take 2 year moving average. Okay, now what I will do, I will take 2 year moving average. I will take 2 year moving average. Okay, sir, how we will take 2 year moving? After 2 year, I will take 3 year moving average. Okay, like this, you can take 4 year, 5 year, like that. Okay, you can take moving average for any number of years, but let me tell you what is moving average. See, if you want to take 2 year moving average, you have to take average of two values. Okay, take the average of these values. Tell me how much you are getting here. Take the average. Yes, take the average of those two values, 10 and 12. Tell me what is the average of 10 and 12. Tell me how much we are getting here. So the average of 10 and 12 is nothing but 11. Okay, this is 11. Then take average of 12 and 30. Average of 12 and 30 will be, this is 18. Yes, it will be 21. Then take average of 30 and 22, it will be 26. Then take average of 2 years. Okay, 2 year moving average means take average of two values. Take average of two values. Here you will get it as how much? 19. Now plot them. Okay, so 11, 21, 26, 19. 11 will be somewhere here. We have to plot it. We will plot it with different ink here. Okay, I will use orange color for the 2 year moving average. 11, 21. So 11 will be here. This is 11. Then we have 21. 21 will be somewhere. 21 will be somewhere here. Okay, so this is 21. Then we have 26. 26 will be somewhere here. Okay, 26 will be somewhere here, and at last we have 19, which will be somewhere here. Okay, join them. This is 11, 21, 26 and 19. Now can you see the range? Now can you tell me the range? Range is between 11 to 26. Okay, now you can simply see that range has decreased. Yes or no? It is from 11 to 26. The minimum value is 11 and the maximum value is 26. See, initially the range was of the gap was of 20, but now when you have taken 2 year moving average, obviously this range has reduced to 15. Okay, range has reduced. Yes or no? Range has reduced or no? Yes, so fluctuations has reduced. Yes, perfect. Now similarly, if you will take 3 year moving average, in a similar fashion, if you will take 3 year moving average, in 3 year moving average we have to take average of three values. Okay, take the average of these three values. 10 plus 12 plus 30 is what? 52, I guess. 52 divided by 3 is what? 52 divided by 3 is 17.33. 17.33. We will write the values in the middle of these. Okay, in the middle of these we will write here. It will be 17.33. Then sum all these three values: 12, 30, 22. 12, 30 is 42, then 22 is what? 42 plus 22 is 64. 64 divided by 3 is what? 21.33. Then take the sum of these values. 30 plus 22 is what? 52. 52 plus 16 is 68. 68 divided by 3 is how much? 22.30, 68. Yeah, 68 by 3. 68 by 3 is 22.67, I guess. Okay, so these are the three values. Now if you will plot them, okay, in front of 2 you have to plot 17.33. It will be somewhere here. 17.33 will be somewhere here. Then we have 21.33. 21.33 will be here. and at last we have 22.67. At last we have 22.67, which will be somewhere here. So you will join this line, okay, which is showing you 3-year moving average. So white line basically is giving you 1-year moving average. Okay, white line here is giving you 1-year moving average. Let me write here so that it is more clear to you. See, white line is giving me 1-year moving average. Okay, this orange line is giving you 2-year moving average, and this blue line is giving you 3-year moving average. Can you tell me where the fluctuation is least? Yes or no? See, in the 3-year moving average, the fluctuation is least. Sir, you can see that all these values are merely fluctuating from 17.33 to 22.67. Maybe maybe average is wrong, but I hope the concept is clear to you. I'm just trying to explain to you, explaining the concepts. Okay. Yes, fluctuations have decreased because we have taken bigger averages. Now, if you will take 5-year moving average, 6-year moving average, obviously the fluctuations will reduce. So overall, sir, if I want to understand the trend of rainfall, overall, if I want to understand, see, obviously the data will not be this small. Okay, obviously 5 data will not be there. You will have a 30, 50 like that data. Okay, you will have huge data. So in that case, it is very useful. Okay, I have only taken very small data so that you are able to understand the graph. Okay, so basically when you see 3-year moving average, basically when you see the graph of 3-year moving average, you will get the trend of rainfall. Okay, see, basically this is done to understand the trend of rainfall. If someone asks you like why we do moving average method, you will say you will simply say, sir, it gives the trend of rainfall. Sir, it gives me the trend of rainfall. Yes or no? It gives me the trend of rainfall. So there is no need to write all the single values. Simply take 3-year moving average, simply take 5-year moving average, and try to understand the trend, whether your rainfall is increasing or decreasing with passage of time. Yes or no? So from this 3-year moving average line, you can see that overall your rainfall is increasing. Okay, overall your rainfall is increasing year by year. Okay, like this. So it will give you the trend of rainfall with very less fluctuations. Okay, so let me write one more important point here, that it smoothens out it smoothens out the fluctuations. It smoothens out the fluctuations in rainfall record. Yes or no? It smoothens out the fluctuations in rainfall record. Okay, so this is your moving average method. Clear? Yes, if you have 30 years data, you will get more idea. Absolutely correct, Vishal. So this is your moving average method. So I hope all these 3 data presentation techniques are very clear to you: mass curve, hydrograph, and your moving average method. Okay, so I hope these 3 are very clear to you. Now we'll move on to some questions. Okay, now you have to solve some questions. After those questions, we will move on to the next topic tomorrow. Okay, obviously we'll solve them tomorrow. So let us solve some questions now. Let us solve. See, obviously after finishing each class, we will practice some questions because questions are very important. Try to solve it in the live class itself. Okay. Okay, so tell me the answer to this one. Try to solve it. Can you tell the answer to this one? See, we have discussed this concept already. Okay, coefficient of variation concept we have already discussed. So this question is saying variability of annual rainfall in India is least in regions of, see, I already told you. Okay, Sushil is saying C option. Okay, let us check. See, I have already told you that wherever we have less rainfall, there we have more variability. Okay, like in desert areas, sir, you told me that in desert areas where there is less rainfall or scanty rainfall, sir, there we have more fluctuation. Variability is more as compared to your coastal regions, as compared to your places of high rainfall. Okay, places of high rainfall have less variability. This we have already discussed. Okay, so the very first one is saying we have least variability in regions of less rainfall. No, this statement is absolutely wrong, because sir, we have more variability in regions of less rainfall. Okay, so this statement is absolutely wrong. Perfect. Then what this second statement is saying, it is largest in regions of high rainfall. Sir, no. In high rainfall regions like coastal areas, okay, hilly areas, there we have less variability. So again, this statement is wrong, because variability is least, not largest. Then it is least in regions of high rainfall. Yes, it is least in regions of high rainfall. Yes, such as coastal regions. Okay, in coastal regions or in hilly regions. Okay, in coastal regions or hilly regions, we have less variability. Variability is less. This is the order of variability. This I have already discussed. So in coastal areas, we have less variability. So obviously the last statement will be wrong. I hope this is very, very clear to you. So this I have already told you. So simple question. Such type of questions can be framed in your state examinations. I hope it is very, very clear to you. Perfect. C option is absolutely correct, Sushil. Great. Now we'll move on to the next question. So what's the next question? See, in this question you are saying the normal annual rainfall at station ABC in a meteorological homogeneous region are 175. Okay, let me write here. Normal values are given to us, A, B and C. Normal values are given to us as 175, 180 and 150. Okay, see, these three are what? Sir, these three are normal values. Sir, these three are normal precipitation values. Okay, this we have already discussed. Okay, perfect. Now in the year 2000, in 2000 year, station B was inoperative. That means station B data is missing. Okay, and they are recording precipitation in which year? 2000. Okay, 23 years previous data. Okay, so B was operated and A and C are giving you reading as 150. A is giving you 150 and C is giving you 135, which this question is saying respectively. Then find the annual rainfall at station B. Okay, so what will be the rainfall if we will estimate it? See, first we have to understand like which method we have to apply. Sir, either we have to apply arithmetic mean method or normal ratio method. How we come to know about it? How we come to know about it? Can you tell me? Kindly tell me how we will find that why I have to use arithmetic mean or normal ratio. Sir, you have told us today that the data which is missing. Okay, sir, station B data is missing. I will use this normal rainfall. Okay, I will use this normal rainfall. And first I will decrease it by 10%. First I will decrease it by 10% and then I will increase it by 10%. Okay, 10% of 180 is simply 18. Okay, subtract 18 from 180 and then add 18 to 180. What you will get? You will get 162 here and here you will get 198. Yes or no? This I have already told you. Now you have to check the remaining normal values. You have to check the remaining normal values. Check if the remaining normal values at station A and C are within the 10% range of C, within the 10% range of B, within the 10% range of B, or they are not coming within this range. Are they lying in this range or are they falling outside this range? Can you tell me? Can you tell me? Yes, 10% range we have to check. So tell me, 175 is within this range or not? Sir, 175 is coming within this range. Yes. Then we have to check 150. 150 is not coming between this. 150 is not coming between this. So, sir, what I will do here? Sir, what I will do here is I will write like this, because 150 is not coming in this range. So obviously it is going outside. So now it simply means if any single value is going beyond this range, sir, which means I will apply normal ratio method. Yes or no? I will apply normal ratio method. Perfect. It is not lying. One of the values is going outside this range, so I will not apply this. Now I have to no, I will not apply arithmetic mean method. I will apply normal ratio method. Okay, sir. How to apply normal ratio method, sir? Simple formula is normal ratio of station B, P by N, sorry. Normal ratio of station B, normal ratio of station B, normal ratio of station B will be sought out simply by taking average of normal ratios of the given values. Okay, normal ratio of A and normal ratio of C. So can you tell me how much you are getting? Can you solve and tell me what answer we are getting here? So precipitation at B we have to find out, and normal at B is 180. M is the number of working stations. Here we have 2 working stations. Yes or no? Perfect. How much we are getting here? Yes, Sushil. P upon NA is 150 upon 175. 150 upon 175, and here we have PC upon NC 135. 135 upon 150. So if you will solve it, you will get PB as, Sushil is saying answer is coming out to be 158. How much you are telling? 158.143 you are saying. Okay. So 158.143 means 158.1 you are getting, simply rounded off. So A, B, C, D, C option will be correct. Okay. C option will be correct here. So I hope with the help of today's explanation, the estimation of missing data, everything is very, very clear to you. Okay. Estimation of missing data has cleared all the concept. I hope now you can easily apply arithmetic mean method also and normal ratio method also. Okay, so I hope this is very clear to you. Now we'll move on to the next question. So no problem is there, I guess, till here. Okay, see, tell me the answer to this one also. This is also very good question. See, I have brought some good questions which you can solve in class. Try to answer this question. Okay, we will take 1 or 2 questions, and after that we'll end our class. After this we'll end our class. Okay, tell me the answer to this one. Try to answer this one. The monthly rainfall at a place A during September 1982 was recorded as 55 mm above normal. Okay, so we have a particular month. They are talking about a particular month, September 1982. They are specific about a month. Great, Sushil. Perfect answer. Perfect answer. You are saying yes. What you are saying here is, what is the meaning of normal here? The rainfall in the same month in the previous year? No. Normal does not mean this. Okay. The rainfall was normally expected based on previous month's data? No. Okay. See, September 1982 normal value is not based on August value. August is the previous month. It is not based on that. Okay. Average rainfall computed from past 12-month record? No, this is also wrong. And the last one is average monthly rainfall for September computed from a specific 30-year of past record for that particular month, September. For September 1981, for September 1980, like this we will take last 30-year data and we will take average. That is normal. Okay, yes, D option is correct here. Okay, that means you have fully understood the concept. This means that you have, Sushil, you have fully understood the concept. Yes or no? I hope this is very clear to you. So normal is basically your last 30-year average data. Okay. Okay, we will not solve this long question. We'll solve some small questions and then we'll end. Okay, see, solve this question from home. Okay, this is your homework question. I will give this question in the slide so that you can download it from the app. You all know that from PW app you can download the slides. Okay, download the PDFs from where you can solve it. Okay, from where you can revise or whatever you want to do. So try to solve this question from home. After this we will solve some small questions. Okay, so tell the answer to this one. What is the meaning of mass curve here? Comment everyone. The mass curve of rainfall of a storm is a plot of what? Rainfall depth for various equal durations plotted in decreasing order. No. Rainfall depths for various equal duration plotted in decreasing order? No, this is not the case. Rainfall intensity versus time in chronological order. See, rainfall intensity versus time is nothing but hydrograph. Yes or no? This we have already discussed today. Rainfall intensity versus time is what? Hydrograph. Okay, sir. Then accumulated rainfall intensity versus time. Accumulated rainfall intensity versus time is not the correct answer because see, mass curve was accumulated rainfall versus time. Yes, D option is correct here. Absolutely correct. D is the correct answer. Accumulated rainfall versus time is the correct answer. Accumulated precipitation, cumulative rainfall versus time is the correct answer, which we have discussed today. Okay, not accumulated rainfall intensity. Intensity is different and precipitation is different. So this is mass curve, which we have already discussed. I hope it is very, very clear to you. Then tell the answer to this one. Okay, this is the second last question. Cyclonic precipitation is caused by lifting of an air mass due to. See, why circular winding motion is there? Cyclonic precipitation is basically caused because of, yes, Sushil, you are absolutely correct. Perfect. Cyclonic precipitation is basically because of pressure difference. Okay, perfect. Natural topographical barrier is causes your orographic. See, and the temperature difference one cause is causing your convective precipitation. Temperature difference causes your convective precipitation. I hope this is very, very clear to you. Then the last question for the day. Orographic precipitation occurs because of what? Density difference of air masses. See, density difference of air masses happens because of temperature difference, and this is the cause for convective one. This is the cause for convective precipitation. Because of density difference, obviously lighter density air goes up and cold mass comes down. Yes or no? Frontal action, you all know. Hot and cold air meets. Then presence of mountain area. Yes, perfect. Orographic is caused because of C1. Yes. Presence of mountain barriers is necessary to force the moisture laden winds to go up and fall there. Okay, so orographic precipitation is basically occurs because of mountain barriers. Yes, this is it. So we'll end our class today and we'll discuss average depth of precipitation from tomorrow. Okay, average depth of precipitation is very, very important because many questions have been framed in past years in GATE and AC. So thank you everyone. We'll catch up tomorrow and we'll discuss from average depth of precipitation. So stay blessed, take care, stay happy. I hope you all are revising and solving the questions.